Hi, my name is Richa, and we're going to learn about circular motion and rotation. So, one of the first concepts that you need to know is uniform circular motion. So, what that is that it's motion along a circular path in which there is no change in speed, but only a change in direction. What you need to remember is constant velocity is tangent to its path. So we have a circle here. So it'll be like tangent to its path. Say that's the velocity. And constant force is going toward the center of the circle. And also so is centripetal acceleration and it's denoted as AC, subscript with the C. And it goes through the center of the circle. And the magnitude of centripetal acceleration depends on its object speed, v, and the radius, r, of the circular path according to the equation AC equals v squared over r. So this is one of the equations that you need to memorize. It's very essential for uniform circular motion, so you must memorize this. And you also need to know that centripetal force is mass times centripetal acceleration, which is just simply mass times v squared over r, since v squared over r is centripetal acceleration. So here's a simple example. It's pretty easy. You'll get more complicated problems once you go into AP Physics, but right now we're just teaching the basics. It's like really good practice if you just know this now. If you know this, then you'll be fine with the more complicated AP Physics problems. It just requires more thinking. So let's just get started. So it says, an athlete who weighs 800 newtons is running around a curve at a speed of 5.0 meters per second in an arc whose radius of curvature r is 5 meters. Assuming his weight is equal to the force of static friction, find the centripetal force acting on him. So it says you could write your givens and finds depending on what teacher you have, but you could do that. But since this is an easy problem, you don't have to. But it'll be helpful for you in the exam. So you can write your given, find, and also a draw. Especially that will help for more complicated problems for you to think through, and it'll be more organized. But this is easy, like I said. So you have to find the centripetal force. So all you need to remember is the equation for a centripetal force. So that's just mass times centripetal acceleration. So it'll be mass times v squared over r. Now it says his weight is equal to the force of static friction. Therefore, if you think about it, you do the weight over g, and g is just 9.8 newtons per kilograms. So you just plug in the numbers because you have the weight as 800 newtons. So just plug in the numbers, you have velocity, you have radius, and you get 400 newtons. Simple. Now for another example for uniform circular motion. This problem is a banked curve problem, which is very essential to know for AP Physics material. But if you don't get it right now, don't sweat it. Just look through this. If you get it, great. It's really not that hard. But if you don't, then, your teacher will have a better job of explaining it. But this is actually pretty good. So let's just continue. So if a roadway is banked at the proper angle, a car can round a corner without any assistance from friction between the tires and the road. Find the appropriate angle for a 900 kilogram car traveling at 20.5 meters per second in a turn of radius 85.0 meters. And there's a picture there to help you. So all you need to do is draw your free body diagram. That is very essential. It's not even like a option not to do it. You have to draw your free body diagram. So going to the solution on the next thing. So once you draw your free body diagram, which you should know about the forces video, so you need to find the forces in the y direction and set it equal to 0. So simple like forces problem. So you do that, and then you solve for n, or Fn in this case, and then you find the forces in the x direction, and the only force in the x direction is the centripetal force. So it's mv squared over r. And then you do a substitution in the equation above. And then you solve for theta. And then you substitute the numerical values. To explain more on this, n equals mg over cosine theta, which we found solving for n. So all you do is just plug it in. That's what that means. Sorry if I confused you. And then you get this. So and then sine theta over cosine theta is tan, and then these m's cancel out right here because you have to set it equal to each other. And then and then you bring the g over here, so it'll be v squared over gr, and then from there you find the angle, then substitute the numerical values like I said before. Pretty simple. It's actually very simple. Just need to memorize those two formulas that I showed you and just know how to do forces problem, which you should already know from regular physics. So yeah. Alright, the next thing you need to know is torque. Torque is actually pretty hard in AP Physics, so we're just going to go through the simple stuff. So once you get the simple stuff, obviously you're going to get the harder stuff. So let's do torque. So a torque is an influence which tends to change the rotational motion of an object, and what you really need to know about torque is obviously the formula. So torque is denoted by tau, which is like a squiggly T kind of. That's what you could say. And then it is equal to the radius times force times sine of an angle. So you need to know the angle, the force, the radius in order to find torque. And here's a helpful diagram to help you visualize how this works. So this is like a lever arm, for example. So a lever arm is measured from the axis of rotation. This is also called the pivot point, and it's very helpful for you to determine and label your pivot point. And this is the radius from axis of rotation to point of application of the force. This is your angle, obviously. The lever arm is r sine theta. The point of application of the force, applied force. So force, okay, moving on. So example 1. In a hurry to catch a cab, you rush to a frictionless, swinging door and onto the sidewalk. The force you exerted on the door was 50 newtons, applied perpendicular to the plane of the door. The door is 1 meter wide. Assuming that you push the door at its edge, what was the torque on the swinging door, taking the hinge as the pivot point? So as we get closer to this, you draw your picture, but right now I already gave it to you. So it says the hinge is a pivot point. So you could draw the door. So this is the pivot point. You have to label it. And then it says the door is 1 meter wide. So you label that. And the force enacted upon it is 50 newtons. So those are your givens after your draw. That's very helpful, especially for these kinds of problems. Like I said, it's very complicated. Torque is very complicated. But, so you do the formula, obviously, and then you could find, the radius, the force, and then the angle is right here. So the angle is obviously 90 degrees. So since you know your angle, you know everything about the formula. You just plug it in and you get 50 Newton meters. Torque's unit is Newton meters, so you need to keep that in mind. But yeah, that's pretty much torques in a simplified manner. But that's like the basics that you need to know. Okay, another thing you need to know is equilibrium. So an object at equilibrium has no net influences to cause it to move, either in translational, linear motion, or rotational. So the basic conditions for equilibrium that you need to know is that the net force is equal to 0. So the x and y components of force may be separately set equal to 0. The forces of the left equal the forces to the right. Forces up is equal to forces down. And the axis may be chosen for advantage to eliminate some unknown forces. Another thing you need to know is net torque is equal to 0. And the sum of the clockwise torques is equal to the sum of the counterclockwise torques. So let's just keep this in mind. This is what you need to know about equilibrium. We're not going to do an example problem, considering we did like an easy torque problem. But this is just one of the things you need to know. So yeah. Another very important topic you need to know is rotational kinematics and dynamics. This is actually generally simple because this is just like the rotational analog of stuff. So yeah, let's just get started. There's just a lot of formulas to memorize, but it's really not that bad. So yeah, let's just get started. A general radian angle, delta rad, or the angular displacement, subtends an arc length, delta s, equal to r. So the theta in this case represents angular displacement. So one of the equations you memorize is the angular displacement is equal to arc length divided by the radius. Now, if you rearrange this equation and divide by delta t, so we rearranged it, and then we divide by delta t, you get V equals r omega